So we are taking few more questions on computer graphics. What is aliasing? What is aliasing? The related question will be what is anti-aliasing? In the line drawing algorithms, all rasterized locations do not match with the true line and have to represent that is do not match with the straight true line and have to represent a straight line. And this problem is severe in low resolution screen. And in such screen, the line would appear like this. There is a stair step shape will be there, and this is known as aliasing in computer graphics. And in image processing, the similar aliasing is when the sampling is not done properly, then this effect is seen in the images. What is anti-aliasing? The process of adjusting intensities of the pixel along the line to minimize the effect of aliasing is anti-aliasing. What is pixel phasing? Pixel phasing. It is an anti-aliasing technique, pixel phasing. The stair steps are smoothed by moving the electron beam to more nearly approximate positions specified by the object geometry. What is transformation? Transformation. It is the process of introducing changes in the shape, size, and orientation of the object using scaling, rotation, reflection, shading, translation, etc. So if this is the object, we translate it, it will move here. If we shear it, it will look like this. If we rotate it, it will look like this. Right? And reflection, of course, to the mirror or any axis, this look like this. These are all transformation, and these are simply matrix multiplications. Write short notes on active and passive transformation. Short notes. Active transformation, the points represent different coordinates of the same coordinate, x and x prime. Here all the points are acted upon by the same transformation, and hence the shape of the object is not distorted. That is, x is equivalent to x dash. In the passive transformation, on the other hand, the points x and x prime, they represent the same point in the space, but they are in a different coordinate system. So the change in the coordinates is merely due to the change in the type of the user coordinate system. What is translation? If this is an object, you can move it to this location. So this is a translation example. So translation is the process of changing the position of the object in a straight line path from one coordinate location to another coordinate location. And every point x, y will go the displacement, every point to x dash, y dash. So x dash will become x plus tx. Tx is the translation parameter. Y dash would be y plus ty. And it is nothing but the mathematics multiplication of xy with tx, ty. What is the scaling? Scaling. See, if I have this object, I can scale it like this. It will become this. I can again do it like this. This is a scaling. Scaling transformation changes the shape of the object, and it's carried out by multiplying each vertex by a scaling factor sx and sy. Sx and sy, where sx is the scaling factor of x and sy is the scaling factor of y. What is shearing? If you press this object, it will look like this after being pressed. So shearing transformation actually slants the object along the x direction or the y direction as required. This transformation slants the shape of the object along the required plane. What is reflection? Reflection. The reflection is actually the transformation that produces a mirror image of an object. This is a mirror image. For this, we use some angles in the lines of reflection. This is a line of reflection, certain angle. Viewport and window port. Distinguish between the window port and the viewport. A portion of a picture that is to be displayed by a window. A portion of a picture, say this portion, which is to be displayed by the window is known as the window port. And the display area of the part selected or the form in which the selected part is viewed is known as the viewport. What is clipping? Clipping is if you have this window port or viewport and the object is like this. So you need to shed off these regions. So clipping is the method of cutting a graphics display to neatly fit a predefined graphics region or the viewport. What is exterior clipping or covering? This is opposite of or clipping reverse. That is, this removes the line coming inside the windows and displays the remaining. So the covering is mainly used to make labels on the complex pictures. What is the need of homogeneous coordinates? Homogeneous coordinates. To perform more than one transformation at a time, we use homogeneous coordinates or matrices. So they reduce the unwanted calculation intermediate steps and saves time and memory and produces a sequence of transformation and also try to tell us the infinite condition. For example, if Tx, say translation is like, also let us scale it, Sx, say 0, 0, Sy, 0, 0, 0, 0, 1. So now what you are doing is Sx and Sy can be done in the 2 dimension, but you are using a homogeneous coordinate. So when you are taking x, y or Sx, Sy and 1, this is your homogeneous coordinate. You are just making it to do all this stuff. That means you want to reduce the unwanted calculation, the intermediate steps, and also save time and memory to produce a sequence of transformations. Uniform scaling and differential scaling distinction or distinguish between uniform scaling and differential scaling. So when the scaling factors Sx and Sy are assigned to the same value or they are same value, uniform scaling is produced that maintains the relative object portions. You can also say the aspect. The unequal value of Sx and Sy, the result in differential scaling that is often used in the design application. What is fixed point scaling? Fixed point scaling. The location of a scaled object can be controlled by the position called the fixed point, which is to remain unchanged after the scaling transformation. This is called fixed point scaling. Various text clipping. Let's saw the various text clipping technique or ways. First is all or none string clipping. That is, if all the string is inside a clip window, keep it, otherwise discard. All or none character clipping, that means discard only those characters that are not completely inside the window. Any character that either overlaps or is outside a window boundary is clipped. Individual characters, if an individual character overlaps a clip window boundary, clip off the part of the character that are outside the window. These are different types of clipping. What are the various representation schemes used in 3D objects? BRES, that is the boundary representation. We describe the 3-dimensional object as a set of surfaces that separate the object interior from the environment. The other is space partitioning representation. We describe the interior properties by partitioning the spatial region containing an object into a set of small, non-overlapping, contiguous solids. What is a polygon mesh? Polygon mesh. This polygon mesh is a method to represent a polygon. When the object surfaces are tiled, it is more convenient to specify the surface facet with a mesh function. See, like this, I can show things like this, taking the points and joining them with, say, some polygon. In this case, I am taking polygon as a triangle. So the various meshes are, say, triangle strip, connected triangles, and minus 2 connected triangles. It can be quadrilateral mesh like this, and it generates n-1 into m-1 quadrilateral. Surface patch. What is a surface patch? A single surface element can be defined as the surface traced out as 2 parameters u and v, and it take all possible values between 0 and 1 into parameter representation. Such a single surface element is known as a surface patch. What are the advantages of rendering polygons by scanline method? Scanline method. The maximum and minimum values of the scan can be easily found. The intersection of scanline with edges is easily calculated by just simple incremental method. And the depth of the polygon at each pixel, is easily calculated by the incremental method. Advantage of rendering by patch splitting. First, it is fast, especially on workstation with hardware polygon rendering pipeline, and it speeds can be varied by altering the depth of the subdivision. B-spline curve. Define the B-spline curve. A B-spline curve is a set of piecewise, usually cubic, polynomial segments that pass close to a set of control points. However, this curve does not pass through these control points. They are not passing through this, but they are controlled by these control points. It only passes which close to them. So these point control. So these are B-spline curve. What is a spline? To produce a smooth curve through a designated points, set of points, a flexible strip called spline is used. Such a spline curve can be mathematically described with a piecewise cubic polynomial function whose first and second derivative are continuous across the various curve section. What is the use of control points? This spline curve can be specified by giving a set of coordinate positions called the control points, which indicate the general shape of the curve. Can easily specify the spline curve. What are the different ways of specifying a spline curve? First of all, using a set of boundary conditions that are imposed on the spline, using the state matrix that characterizes the spline, and using a set of blending functions that calculate the position along the curve path by specifying combination of geometric constraints on the curve. What are the important characteristics or properties of Bezier curve? First is Bezier curve, it only needs 4 control points. It always passes through the first and last control point, and the curve lies entirely within the convex half formed by the 4 control points. Differentiate between interpolation spline and approximation to spline. When the spline curve passes through all the control points, it is called interpolate or interpolation. When the curve is not passing through the points, all control points, then the curve is called the approximate spline. What do you mean by parabolic splines? Parabolic splines. The parabolic splines are parabola, parabola, like this or like this. So for parabolic splines, a parabola is fitted through first 3 points, P1, P2, P3 of the data array of the dot points. Then a second parabolic arc is found to fit the sequence, say P2, P3, then P4. So next will be P3, P4, P5. So this continues in the way until a parabolic arc is found to fit through the points Pn minus 2 to Pn. And the final plotted curve is a mesh, or it is a meshing together of all these parabolic arcs. What is cubic spline? Cubic spline are a straightforward extension of concept underlying the parabolic spline. The total curve in this case is a sequence of arcs of cubic rather than the parabolic curves. Define the Octrees. For 3D, we use Octree 3D representation, or space partitioning and various other aspects. So these are the hierarchical tree structure called the Octrees. These are used to represent solid objects in some graphic system. Medical imaging and other application that require space of object cross sections commonly use this Octree representation. The 2D counterpart of Octree is quad tree. Define the projection. Projection means converting 3D to 2D means if you want the things to be planar, you need to convert the 3D point to map it on a plain paper or a screen. This is a projection. So the process of displaying 3D into 2D display is known as projection. The projection transforms 3D objects into a 2D projection plane. So what are the steps involved in 3D transformation? First, modeling transformation, viewing transformation, project transformation, and then the workstation transformation. So first you have points, you make models from these points, then you do the viewing transformation, then finally the projection one means orthographic or perspective projection. In viewing you can have various shading aspects, and we have groove, shading and point and all those aspects to make these 3D more realistic, like radiosity you can add all these, then the projection, and then finally to show it on the screen you have workstation transformation. What do you mean by a view plane? A view plane is nothing but the plane, a film plane in camera which is positioned and oriented for a particular shot of the scene. What is view plane normal vector? View plane normal vector. Now, the normal vector is the direction perpendicular to the view plane, which is called as a dx and dy and dz. What is view distance? View distance. A view plane normal vector is a directed line segment from the view plane to the view reference point. So this view plane normal vector, it is a directed line segment from the view plane to the view reference point. This length of this directed line segment is referred to as the view distance. This one. Again, projection, the process of converting the description of object from world coordinate. This is another definition. So from world coordinate system or world coordinate to the viewing coordinate is known as the projection. So what do you mean by parallel projection? The parallel projection is one in which the z coordinates is discarded and parallel lines from each vertex on the object are extended until they intersect the view plane. Parallel projection. So perspective projection. The perspective projection is one in which the lines of the projections are not parallel. So they will they will point or converge. So they all converge at the single point called the central projection. Like the way we see, human eye, they use perspective projection only. The objects which are far off, they appear to be smaller than the object which are nearer to our eye. What is the projection reference point? In perspective projection, the line of projection are not parallel. They all converge at single point, which is known as the projection reference point. What is the use of projection reference point? In the perspective projection, the object positions are transformed to the view plane. The object positions are transformed to the view plane along this converged projection line, and the projected view of the object is determined by calculating the intersection of the converged projection lines with the new plane or view plane. What are the different types of parallel projections? The parallel projections are basically characterized into two types, depending on the relationship between the direction of projection and the normal to the view plane. So they are orthographic parallel projection, and the oblique projection. What is orthographic parallel projection? What is orthographic oblique projection? So orthographic parallel projection, when the direction of the projection is normal, perpendicular to the view plane, like this, then the projection is known as the orthographic parallel projection, and when it is oblique, like this, when the projection of the direction of the projection is not normal, not perpendicular to the view plane, then the projection is known as the oblique projection. What is axonometric orthographic projection? The orthographic projection can display more than one face of the object. Such an orthographic projection is called as axonometric orthographic projection. You'll see the front view, side view, top view. What is vanishing point? The perspective projection of any set of parallel lines that are not parallel to the projection place, they converge to point known as the vanishing point. What do you mean by principal vanishing point? The vanishing point of any set of lines that are parallel to one of the three principal axes of an object is referred to as the principal vanishing point or axis vanishing point. So what is view reference point then? The view reference point is the center of the viewing coordinate system. It is often chosen to be close to or on the surface of the same object in the scene. So these are a few more questions on your computer graphics. Thank you so much. Take care.